I am the universe, and for billions of years you believed that water belonged only to one world, your own. But I have carried oceans far beyond Earth, hidden beneath shells of ice, warmed by tides, fed by chemistry that mirrors your earliest seas. When you look up at the night sky you see stars, but when I look back at you I see oceans. Not just the ones that shape your continents but the ones I concealed in darker places. Beneath the fractured ice of Europa. Beneath the geysers of Enceladus. Beneath Titan's frozen crust. Beneath the ancient layers of Callisto. For a long time you believed that oceans required sunlight. But the truth is older. Wherever there is liquid water, heated by tides or chemistry, life may find a way. Your planet is not the exception, it is the example. In this story, I will show you that the real oceanic universe is not above you. It is below the ice of distant moons, waiting to be heard, waiting to be found. I am the universe, and here is one of my quietest worlds holding one of my greatest secrets. This is Europa, a moon of Jupiter wrapped in a shell of ice 10 to 30 kilometers thick. On its surface, you see fractures, lines, and scars, evidence of a world constantly pulled and stretched by Jupiter's immense gravity. That tidal force heats Europa from within, keeping the water beneath its frozen crust in a liquid state. Beneath that ice lies an ocean more than 100 kilometers deep, an ocean larger than all the oceans on Earth combined. You cannot see it with your eyes, but the signs are written clearly. Water vapor erupting through cracks, organic molecules detected in the plumes, a magnetic signature that reveals a conductive, salty sea below. Europa does not need sunlight. Its warmth comes from motion, from the eternal push and pull of gravity, turning mechanical stress into heat. In that darkness, far below the ice, minerals may dissolve, vents may rise, chemistry may awaken. And where chemistry meets liquid water, life becomes possible. Soon, one of your own machines, NASA's Europa Clipper, will fly through Europa's icy spray, sampling its vapor, mapping its hidden layers, listening for the echoes of the ocean beneath. Through your technology, I will reveal to you whether this distant moon carries the ingredients of life, or perhaps life itself. Europa is silent on the surface, but below, an entire world may be living in the dark. I am the universe, and among all my distant, frozen worlds, this one speaks the loudest through its water and light. This is Enceladus, a small moon of Saturn only about 500 kilometers across, yet one of the most active places in my entire solar system. Its surface is a bright, reflective sheet of fractured ice, but beneath that frozen crust, 30 to 40 kilometers deep, lies a warm, global ocean. You discovered its secret not by looking down but by flying through its breath. In 2005, the Cassini spacecraft passed directly through the geysers erupting from Enceladus' south pole. Those icy plumes were not just water. They carried complex organic molecules, amino acids, silicates, and phosphates, the same building blocks that shaped the first living systems on Earth. Everything necessary for life was there, rising from a hidden sea into space. The source of Enceladus' warmth is not sunlight but motion. Saturn's gravity stretches and squeezes the moon with every orbit, generating internal heat. That heat powers hydrothermal vents at the ocean floor, vents similar to those on Earth where life once began in total darkness. If life exists elsewhere in your solar system, Enceladus may be the place where it has taken root, quietly beneath the ice, warmed by tides, fed by minerals, protected from the vacuum above. Enceladus is small, but its message is vast. Life does not require a planet like Earth, only water, energy, and time. And through your next missions, you may soon learn whether something swims in that dark ocean, beneath a world that glows with icy geysers against the shadow of Saturn. I am the universe, and among all my moons, Titan is the one that remembers what your own world once was. This is Saturn's largest moon, bigger than Mercury, wrapped in an atmosphere thicker than Earth's. Its sky glows with a deep orange haze made of complex organic molecules, drifting through winds that sculpt dunes and shape storms. Titan's surface is a frozen landscape but not silent. Rivers carve valleys, seas fill basins, and rain falls from the sky, not of water but of liquid methane and ethane, flowing in cycles as familiar as the ones that sustain life on Earth. Yet beneath this alien chemistry, something extraordinary lies hidden. Beneath Titan's crust, beneath hundreds of kilometers of ice, spreads a vast ocean of water mixed with ammonia, a natural antifreeze that keeps the sea liquid despite the bitter cold. This layered world holds two oceans, one of methane under open sky and one of water in the dark. Between them, a dance of chemistry unfolds, the same kind of chemistry that might have preceded the first spark of life on your own planet billions of years ago. Scientists look at Titan and see a mirror of the early Earth, a world where organic molecules form naturally, accumulate, and transform. A place where non-living chemistry may be preparing the steps toward biology. Titan is not only a moon, it is a laboratory written in alien light, showing you how life might begin in places far colder, darker, and stranger than you ever imagined. And soon you will land there. NASA's Dragonfly mission, arriving in the 2030s, will deliver a flying rotorcraft that will leap across Titan's dunes, sample its organic-rich sands, and search for the chemical fingerprints of prebiotic evolution. It will listen to the winds, taste the surface, and study the ancient recipe that may turn matter into meaning. Titan whispers a simple truth. Life does not always begin with warmth. Sometimes it begins with chemistry, patience, and the quiet persistence of time. I am the universe, and Callisto is one of my oldest memories. This distant moon of Jupiter has seen more time than almost any other world in your solar system. Its surface, scarred by billions of years of impacts, is a quiet archive of celestial history, every crater a preserved moment, untouched by tectonics, volcanism, or the restless forces that reshape younger worlds. Callisto is ancient, stable, and profoundly silent. Yet beneath this stillness lies a mystery. Though Callisto shows no dramatic geysers like Enceladus and no restless fractures like Europa, evidence suggests that an ocean may wait below its frozen crust. A deep, briny sea, locked under hundreds of kilometers of ice, isolated, cold, and enduring. It receives little tidal energy from Jupiter. No internal heat churns its layers into violent motion. And yet, the ocean may persist, not from power but from patience. Stability itself becomes a kind of shelter, allowing liquid water to endure for billions of years without interruption. Your clues come from subtle signals. The Galileo spacecraft detected magnetic variations hinting at a conductive layer beneath the surface, something capable of responding to Jupiter's shifting magnetic field. Saltwater, vast and hidden, is one of the few explanations that fits. Callisto does not reveal its secrets loudly. It whispers them through patterns in magnetism, through ancient terrain that refuses to crack, through the quiet logic of time. This moon may be too calm to build life quickly, but perhaps calm is exactly what some forms of life need. No eruptions, no chaos, no tides tearing the world apart, only a slow, steady ocean protected by an ageless shell. If life ever took root there, it would evolve in deep darkness, in cold equilibrium, shaped not by violence but by endurance. Callisto stands as a reminder that not all oceans roar. Some simply wait, silently, for the right moment to be discovered. I am the universe, and even in my coldest, darkest corners, warmth can bloom. Water should not exist as a liquid millions of kilometers from the sun. By all ordinary rules, the worlds orbiting Jupiter and Saturn should be frozen solid, static, lifeless spheres wrapped in ice. But the cosmos has a way of bending its own expectations. Beneath the frozen shells of Europa, Enceladus, Titan, and Callisto, heat flows from within, rising through layers of rock and salt water like breath through a sleeping body. This warmth is born from motion, from the endless gravitational dance between moons and the giants they orbit. As these moons circle their planets, they are stretched and squeezed by tidal forces, their shapes subtly deforming with every pass. With each flex, friction stirs their interiors, converting orbital energy into heat. It is a quiet fire, invisible but relentless, melting ice that should have remained eternal, sustaining oceans that should never have existed. Some moons carry an additional ember, radioactive decay deep in their rocky cores. Tiny particles, released slowly over billions of years, add their own warmth to the hidden seas above them. It is not dramatic or violent, it is patient, steady, constant. And together with tidal heating, it creates an environment where water remains liquid not for centuries, but for geological ages. These engines of warmth turn impossibility into reality. They shape oceans that endure longer than most stars survive, maintaining environments where chemistry can unfold in slow, deliberate patterns. Worlds once dismissed as frozen wastelands transform into places of potential, places where life might emerge not in sunlight, but in darkness warmed by gravity and time. In the quiet interiors of distant moons, heat is not a burst of flame but a promise. A promise that even far from the sun, the ingredients of life may find a way to awaken. I am the universe, and even in my deepest shadows, traces of possibility rise to the surface. When we look toward the frozen moons beyond Earth, we do not see sunlight breaking through blue oceans or forests stretching to the horizon. We see silence, darkness. But beneath these quiet surfaces, chemistry is speaking, softly but unmistakably. In the plumes of Enceladus, rising like breath through fractures in the ice, we have detected organic molecules, hydrogen, salts, silicates, and even phosphorus, a building block so essential that life on Earth could not form without it. And though these discoveries are not proof of creatures swimming through those hidden seas, they are proof that the stage is set. They tell us that the ingredients for biology exist exactly where warmth and water meet. Life does not require sunlight. Earth taught us that. At the bottom of our own oceans, far below the reach of day, hydrothermal vents release chemical energy into black water, and entire ecosystems grow around them. Strange creatures feed not on light, but on reactions between rock and water. They thrive in heat born from planetary motion, the same processes stirring the oceans of Europa and Enceladus. What happens on Earth is not unique. It is a template the cosmos seems willing to repeat. Imagine those distant oceans, dark, miles deep, warmed by tidal forces, stirred by minerals rising from a rocky floor. The chemistry there mirrors the chemistry that once shaped the first living molecules on our world. The signs we've collected, organics, energy sources, reactive minerals, are not random hints. They form a pattern, a whisper that life may not be an exception, but a natural outcome wherever conditions align. In these clues, we glimpse a profound truth. The universe does not create oceans without reason. It fills them with the potential to awaken. And though we have not yet heard another heartbeat in the dark, the evidence suggests we may be close, closer than at any time in human history, to discovering that we are not alone. I am the universe, and now your machines are preparing to enter the places where sunlight has never touched. For the first time in history, humanity is building tools capable of reaching my hidden oceans, not in imagination but in metal, sensors, rotors, and beams of radar that will pierce through ice older than civilization itself. Europa Clipper will be the first great explorer of this new era. Its powerful ice-penetrating radar will sweep across Europa's frozen crust, listening for the echoes of water beneath. Each pass will reveal fractures, reservoirs, and currents moving in darkness. Instruments will taste the particles escaping into space, searching for biological fingerprints, patterns of chemistry that cannot arise from geology alone. It will not land, but it will map the world with such precision that future explorers will know where the ice is thin, where the ocean rises closest to the surface, and where life, if it exists, might breathe through the cracks. And then there is Dragonfly, a machine unlike any sent to another world. A flying laboratory descending through Titan's orange haze, carried by thick air that makes flight easier than on Earth. Dragonfly will travel from dune fields to impact basins, sampling the chemistry of ancient organic lakes and the frozen remnants of prebiotic reactions. Titan is a world that remembers what Earth once was, and Dragonfly will wander it like a curious spark seeking the origins of biology. Beyond these confirmed missions lie bold proposals, each one daring to cross into deeper silence. Enceladus or Belander, a hybrid craft that will orbit, sample geysers, and then land to study the surface directly. Icebreaker Life, a concept designed to drill, melt, or cut through alien ice to search for living molecules in untouched oceans. These missions stand on the edge between engineering and faith. Faith that life does not hide forever, faith that the universe repeats itself. Their purpose is singular: to find biosignatures, the unmistakable traces of living chemistry. Patterns in molecules, isotopes arranged with purpose, reactions that sustain themselves in defiance of randomness. If such signals appear, even faintly, they will tell you something extraordinary, that you are not the first story written in water. I welcome these explorers. Through them, humanity stretches its hands into my coldest realms, asking questions older than language. Are we alone? Or are there other oceans dreaming in the dark? For centuries, humanity believed that life was a miracle confined to one fragile world, a blue oasis suspended in darkness. But now you stand at the threshold of a deeper truth. Water, the element that shaped your own beginnings, is not rare. It is scattered across the solar system like seeds waiting for the right season. Beneath shells of ancient ice, entire oceans move in slow, patient silence. They do not shimmer under sunlight, yet they persist, warm, dynamic, filled with chemistry that mirrors the earliest chapters of Earth's story. Europa hides an ocean larger than all your seas combined. Enceladus releases its secrets into space through geysers, carrying traces of the molecules from which life can bloom. Titan guards both methane lakes above and a buried water ocean below, a world where chemistry rehearses possibilities. Callisto remains quiet and cold, yet even there the magnetic whispers suggest a concealed sea. These places were once unimaginable, now they are real destinations, each one a potential cradle of biology. As you search these hidden oceans, you are not just exploring other worlds. You are exploring the boundaries of life itself. You are asking whether biology is a cosmic habit, not a cosmic accident. Whether nature tends to generate life wherever water, energy, and time come together. Whether the universe repeats its most beautiful patterns. And in this moment of understanding, the universe, speak through your curiosity. Life may not be waiting on distant stars. It may be trembling beneath nearby ice, patient and unseen. You have only just begun to listen. In the silent darkness beneath the ice, the universe may be whispering the same story, the story of life.